Hello everyone, this is another video on here we'll be discussing about thermodynamics complete revision. We'll do in this short video. We'll do complete revision on thermodynamics. Okay, let's start. So first of all, we'll write the processes and what the formulas in those processes. This will be like a one-shot video type processes, condition, work done. Okay, processes, conditions, work done. Then state equation and laws followed. Laws followed. Yeah. Processes, conditions, work done, law, state equation, laws. Okay. So first is your isothermal process. What happens in isothermal process? Condition is what? T is constant. That means dt is zero. Right. So work done is what? Here work done is 2.303 nRT log V2 by yeah, or nRT ln V2 by V1, right? Or nRT ln V2 by V1 or nRT ln um, P1 by P2. Okay, P1 by P2. State equation. What is the state equation? PV is equal to constant here. Okay, that means P1 V1 is equal to P2 V2. Which law it follows? It follows Boyle's. Okay, this is an isothermal process. T is constant, dt is zero, W is nRT ln V2 by V1 or nRT ln P1 by P2. Next process is isobaric process. Isobaric process, here pressure is constant, that means dP is 0. W is equal to P V2 minus V1. Yeah, because P is your constant, so PdV, that means V2 minus V1. And here the equation will be V by T is equal to constant. Because we know PV is equal to nRT. Now that P is constant, P will go to that side and nR are constant. And T will come to this side. So V by T will be nR by P, which is constant. V by T is equal to constant. That means V1 by T1 is equal to V2 by T, which will obey what? Charles' law. Okay. Okay. Next is a what? Isochoric process. Isochoric. Isochoric means here volume will be constant. That means dV is equal to 0. Yeah. So here W is equal to what? PdV we know. And as V dV is constant, so this will be 0. Because V2 is equal to V1. V is constant. W 0. And P by T will be constant. Okay. Why? Because again PV is equal to nRT. V is your constant, it will go to that side and PT will come to this side. So PV is equal to nR by V, which is constant. And this is your what? Pressure law. This is called pressure law. Yeah. Next is an adiabatic equation. Adiabatic process for adiabatic. Yeah, adiabatic process. Sorry. Adiabatic process. Here your heat is constant. There is no heat exchange. So dq is equal to 0. Yeah. If dq is 0, we know ds is equal to dq by t integration. So your dq will also be, sorry, ds will also be 0. Okay. And because of that, what will happen? We know dq is equal to du plus dw, right? So du will become minus dw. Okay. Yeah. So here the work done will be w is equal to p1 v1 minus p2 v2 by gamma minus 1. That will be the work done in this process, in adiabatic process. Yeah. Otherwise, you can also write the formula nr by gamma minus 1, T1 minus 2. This is another formula for water. Yeah, right. So here the state equation we got Tv to the power gamma is equal to constant. Tv to the power gamma is equal to constant. V T sorry T V gamma minus 1 is equal to constant. Yeah. Or T to the power gamma P to the power 1 minus gamma is equal to constant. Or we can also write this one as T P to the power 1 minus gamma by gamma is equal to constant. And this is called Poisson's law. It's not required. I mean, leave it. Dv to the power gamma is equal to constant. Dv to the power gamma minus 1 constant. T to the power gamma P to the power 1 minus gamma is constant. Okay. Next is your system and surrounding. That things. So mm, leave it. This is not that. Okay, there are some terms we should remember. Boundary walls, diathermic. What is diathermic? Diathermic is through which heat can be transmitted, through which heat can be transmitted. Then is an adiabatic, through which heat cannot be transmitted. We just saw adiabatic means no heat exchange. So through which heat cannot be transmitted. Heat cannot be transmitted. Okay. Now uh, now there is this internal energy formula. Internal energy. Just remember, internal energy U is equal to 3 by 2 kT. So U is equal to 3 by 2 kT. So for example, du by dv at constant temperature will be 0. Du by dp at constant temperature will be 0. This is for ideal gas. This is for what? Ideal gas. Okay. Another point I know, when gas expands, when gas expands, this what happens? Volume increases. Okay, volume increases. So if volume increases, that will be what? Positive Gordon. Okay. So when gas is compressed, volume decreases. Volume decreases. That is negative water. Okay. That is negative water. And heat Q, work W, both are path functions. Okay, they are not state functions. Both are path functions. But your internal energy U is a state function. Yeah. So another formula work done. Work done is what? Area between PV curve and V axis. Okay. Okay. Another some processes and their properties. This is a different one. Processes and their properties. First is an isothermic process. Here dq will be equal to dw. Why? Because as dt is equal to 0, your du is in cv dt, and that will be 0. Okay, so dq is equal to dw. Okay, if dq is less than 0, that means what? Heat is ejected. Okay, then dw will also be less than 0. If dq is greater than 0, that means heat gained or heat added. Then dw will also be greater than 0. Okay, yeah, this is isothermic. Next is your isobaric. Isobaric is here du is equal to n cv dt. Why cv? Isobaric process volume is constant. Pressure is constant. No, no, sorry. Um, ncp dt. Okay, and your because isobaric means pressure constant. Hmm. And dw will be nrdt. Yeah, so w work done by system is positive, work done on the system is negative. Work done by, like, work by done by you is positive, you are doing the work. Okay, nobody is doing it for you. If someone is doing it for you, or someone is doing it in you, that means they're imposing them on you, that means negative. Think that way. And if you're doing it yourself, that's good for you. So this is positive. You can still do work, that means it's positive. I remember it that way. Next is isochoric. Isochoric is volume constant. Hmm. So dq will be equal to du only, is equal to ncvd. Why? Because as v constant, dw is equal to pdv. So dv is 0. Yeah. So dq is equal to du plus dw is 0. Alright. So if dq greater than 0, then what? Du also greater than 0. And if dq is less than 0, du is less than 0. Okay. Cyclic. Next is cyclic process. In cyclic process, what is this? Summation of dq is equal to summation of dw. That's it. Okay. Cyclic process du is 0. Why? Because du is a state function. That means if suppose it's starting here and ending here, du means like energy at initial point minus final point. That's so initial final are same. So that is at 0. Okay. Next is adiabatic. Adiabatic, what happens? Du plus dw is equal to dq, we know. But in adiabatic process, q remains constant, so dq is 0. So du plus dw is 0. So du is minus dw. Okay. Hmm. So if dw is greater than 0, then du will be less than 0. And if dw is less than 0, dw will be, yeah, because there is a negative sign, so it changes the whole scenario here. Okay. So just write all this first, and I'm just coming in 2 minutes. Okay, so this was your adiabatic. Next, let's see. Next is a heat or thermal capacity. Next is your heat capacity. Heat capacity is what? C is equal to dq by dt, right? That is your heat capacity. So it means heat required to change temperature of any substance, temperature of any substance by 1 degree Celsius. Temperature of any substance by 1 degree Celsius. Okay. So C is equal to dq by dt. Okay. So here the unit is joule per Kelvin. Okay. Now specific heat capacity. This was the heat capacity only. Now specific heat capacity. Specific heat capacity is amount of heat required to change a temperature of a certain mass m. Here mass comes into picture. Certain mass m of any substance. Okay. So here for solid, for solid, specific heat capacity will be Cm is equal to C by m is equal to dq by m dt. Okay. The unit will be joule per kg per Kelvin. Okay. But for liquid, like for gases it will be Cn because mole will come into picture. We don't like mass won't be there, kg won't be there. So dq by n dt, n is a mole, joule per mole per Kelvin. Okay. Yeah. Yeah. So next is your molar specific, molar specific heat. That is at constant volume, at constant volume. Cv is what? dq by n dt. That is du by n dt. Why I wrote dq is du as constant volume means dv is 0. So dw becomes 0. So dq becomes du. Now at constant I can also write du is ncv dt. Okay, at constant pressure Cp is what? dq by n dt. Yeah, n dt. Then that formula where there was a bit of confusion, you can write it as ncv because du is always ncv. Okay? Even it is at p constant. Okay. Okay. Now next, write on heat added or rejected to the system. Heat added to or rejected from the system where phase does not change, phase doesn't change, but temperature changes is what? Integration dq, heat. Okay. mc del theta or a del t or dt, whatever, dt, where T1 to T2 initial to final temperature. Okay. This is used for both heat bath and reservoir. Heat bath and reservoir. Okay. Okay. This is when the phase is not changing, only the temperature is changing. But when the phase changes solid to liquid, liquid to gas, what happens? Then temperature actually remains constant. So this formula won't be valid. Okay. Then that will be called the heat required to like the heat when the phase changes. That is called latent heat. Okay, for liquid solid it will be latent heat of fusion or latent heat of melting, like that. Okay, so heat added or rejected from added to or rejected from the system when phase changes but T does not change. T remains constant. T does not change is what Q is equal to ml. Okay? Q is equal to ml. Q is equal to ml. L is your what? L is your latent heat. Okay? L is equal to your latent heat. Next is your called degree of freedom. Next is your called degree of freedom. Okay? So degree of freedom is 3n minus k. Where what is n, what is k? N is your number of atoms, k is your number of constraints. Hmm. So monoatomic ideal gas. Then there is diatomic. Then there is triatomic. It's linear, non-linear. Okay. So monoatomic gas. Okay. The degree of freedom is what? It's 3. Okay. So your U becomes what? 3 by 2 NKT. And CB is your 3 by 2 R. CP becomes 5 by 2 R. Okay. Gamma is what? Gamma is actually what? 1 plus 2 by F. So 1 plus 2 by 3, that is 5 by 3. Okay. Again for diatomic gas, this is degree of freedom is 5. This one becomes 5 by 2 NKT. Hmm. And this one becomes 5 by 2 R. This becomes 7 by 2 R. And gamma is also CP by CB. You can write that on instead of 1 plus 2 by F. That is 7 by 5. Okay. Now triatomic linear. For linear it is 7. So this becomes 7 by 2 NKT. So if this is 7 by 2, this is 7 by 2, this is 9 by 2, so this is a 9 by 7. Now this one non-linear is 6. 6 by 2 NKT, that means 3. So this is also 6 by 2, that means 3. And this is 4 then, right? 4R. 3R, 4R. Okay, I'm missing the R's here. 3R, 4R. So this is your 4 by 2. See how easy it is, right? How easy it is. Alright, got it? Next come to thermal energy reservoir, whatever. Thermal energy reservoir. Okay. So one is called source, one is called sink. One is source, one is sink. Source is what supplies energy. The source actually supplies energy in form of heat. Form of heat. Sink absorbs energy in the form of heat. Absorbs energy in the form of heat. Okay. So heat engine Heat engine is there is a thing of heat engine. That means there will be source. It will be at a temperature T. Okay, this is a heat engine from which work will be done. Right? What work? So here Q in is equal to Q, okay, QH. So now this is your sink. It is at a temperature TL, suppose. This is a TH. It's TL. Okay, here Q will be out. Right. Q will be rejected here. Q will be rejected. Okay. This is absorbed. Here heat will be absorbed here and work will be done through heat engine W net, and this one will be rejected. Okay. So you can see here W will be what? W net will be Q in minus Q out, isn't it? For example, 20 joule comes in. Some work is done now. 10 joule is getting ejected. So the whole work done is what? 10 joules. So in minus out, not out minus in, because at the end it will be less. Okay. So efficiency is what? It can never increase. If it is increasing, that's not possible. Efficiency is like benefit by loss, isn't it? How much benefit we got, and how much like total was there. Benefit by total, sorry. So output by input. Output is a what? Output is actually a what? Input is what? Q in. Okay, this is what it is. Output is a what? Output is not your Q out. This is only heat rejected. Our work is this one, the one which is important. Okay? So eta is equal to eta efficiency is equal to Q by W Q in. W by Q input. Okay, instead of QH, let me write Q input so that it won't be confusing. Otherwise, eta will be 1 minus Q2 by Q1, or 1 minus Q out by Q in, because Q out is smaller, so it's in the numerator. So, and this is in the denominator because this is bigger. Okay, otherwise it will be coming like negative. Okay, is that all right? This formula is valid for all. Okay, leave it. Okay, here. Now this is heat engine. The refrigerator is exactly the opposite of heat engine. The refrigerator. Okay, here what the like the whole this is cold refrigerated space, heat QL. Okay, this is your refrigerator W in, and this is your what? Okay, this is a warm environment. Warm environment. Okay, so here it's called coefficient of performance. Coefficient of performance. Coefficient of performance of refrigerator is equal to QL by W. Okay, this one Q2. That means Q2 by W. That means Q2 by W. That is Q2 by what is W now? W we know Q1 minus Q2. Yeah. So this should be the formula. That means now what will I do? I will what will I do? Now this much here now. Okay. Now there is second law of thermodynamics from which we are getting the that entropy thing. Okay, from which we are getting the entropy. Entropy Ts is equal to dq by t. Del S universe will be 0 greater than 0, okay, for spontaneous or irreversible process. Spontaneous or irreversible process. Del S universe is equal to 0 for equilibrium or reversible or quasi-static process. Quasi-static process. Okay. And del S universe is equal to del S system plus del S surrounding. Only see, it's an important point. If energy is absorbed by a system, if energy is absorbed by system, then entropy will increase. Entropy increase. If energy is released, energy is expelled or released. See, more energy is absorbed, more the like the particles will have like motion that will increase the entropy. Okay. System released by system, entropy decrease. Okay. For reversible cycles, for reversible cycles, del S universe is equal to 0. Okay, that means del Q reversible by T is equal to 0. Hmm. This is called Clausius statement. Now for irreversible cycles, del S universe is greater than 0, del Q by T is greater than 0. Okay. Okay. Okay, next is a TS diagram. This one is important. TS diagram. Okay. What is this? This is PV diagram actually. This is what diagram. PV means what? The heat diagram is different. This is called TS diagram. Heat diagram. This one is different. It's like a square. Okay. So here, this 1, 2, 3, 4. Okay. If you see, 1 to 2 is called isothermal expansion because here, see, entropy is increasing. As I told, entropy increases, so heat will be increasing because ds is equal to dq by t. So if entropy increases, dq will increase. If dq like your what means expansion, it's expansion. Okay, so this will I will write isothermal expansion. Okay? isothermal expansion, that is Q greater than 0. This one is what? Here temperature, like this one I will call adiabatic expansion. Okay, this one is isothermal, the opposite isothermal compression. Compression Q less than 0. Here adiabatic compression, adiabatic compression. Okay, here Q is 0. Here Q is 0. Why Q is 0? See here, S is constant, isn't it? So if S is constant, ds is 0, so dq is 0, isn't it? Ah, right. Yeah. So here, what is the efficiency? Efficiency is 1 minus, right, T2 or into S1 minus S2 by G1 or into S2 minus S1. The formula. Okay, is that right? Okay, next is thermodynamic potentials. This one I will tell you the way I have remembered. Okay, so great physicists have studied under very fine teachers. Great physicists have studied under very fine teachers. I would write like all the initial letters. Great physicists, I'll start from here. Great physicists have studied under very fine teachers. Okay, so this is it. So if I go from up to down, that will be a positive. Up to down will be positive. But if I go from down to up, that will be negative. Down to up, that will be negative. Okay, what does it mean? How will I write it? See, let's see. So this h, I will write it as dh is equal to, okay, dh is equal to. Now what? Now what? The right side, left side, I will just write dp ds. Okay. Now what? P is going to be that down, so positive. So v dp. S is going to t positive, so plus t. Okay. Is that right? Now, now see du. The right and left side I will just write on ds, dv, these two, the besides it. Then s is going down to t, that means positive. V is going up to p, that means negative, negative p. Okay, this is it. One. Now df, df. Okay, df. Right. What are the side parts? Side arrows. And t is going up to s, that means negative s. V is going up, that means negative. Yeah. Now dg. dg is dp beside dp dt. T is going up to s, that means minus s. P is going down, that means plus b. Okay, that easy. Is that all right? Hmm. Now through these equations, I can write the potentials like potential exactly. For example, dh is equal to vdp per plus tds. So I can write it v is equal to del h by del p. V is equal to del h by 2 when this is constant, s is constant. Because when s is constant, this TDS is 0, so VDP will be DH, right? So V is equal to del H by del P. Exactly, T will be what? Del H by del S when P is constant. Is that alright? Now what will I do? I will just multiply. See, I will do what? Del V by del S, I will do this side is equal to del by del S of del H by del P, del V by del S at del V by del S. I'll just interchange this. Okay, del by del P is the same thing. Don't worry. Del by del S. So del V by del S, stream pressure is equal to del by del P. Now what is del H by del S? Del H by del S is T. So just put it here. Del T by del P. Yeah. So this is one equation. Okay, this is one potential. Exactly like this, we can derive all of the potential from these formulas. Right? Clear? So let me do another one and then you will do the other ones. du is equal to TdS minus PdV. Du is equal to TdS minus PdV. So T is equal to del U by del S at pressure volume constant. P is equal to minus del U by del P at entropy constant. So now del T by del V is equal to del by del V of del U by del S. I'll just interchange it. This will be S. Interchange the that one del by del S of del U by del V. Okay. S is equal to now del U by del V is what? Minus P. Okay. So let's just put it minus del P by del S. Is that alright? Is that alright? Okay. So this is another potential. You can calculate all the other potentials, isn't it? Yeah, I hope you can calculate. Then just another write another formula. Chemical potential. Chemical potential mu is equal to del U by del N S V. Yeah. Or mu is equal to del F by del N T V. It's these two formulas right now. Now just write down extensive variables. So these ones now these are called your Maxwell's thermodynamic relations. The ones I have done, just two equations I have done. You just do this, okay? Maxwell's thermodynamic. No need to do it through shortcut. Okay, it's better to do it. You will get enough time. Like more you practice, you will do it faster. All right. Next is your next is extensive variable. Extensive variable and intensive variable and intensive variable. Extensive variable and intensive variable. So extensive variable means what? Mass, volume, internal energy. Okay, internal energy. Then entropy, length. These are your extensive variables. And temperature, pressure, volume, viscosity. These are your intensive variables. Right? Yeah. Next, write down energy equations. Energy. Energy equations. So fast energy equation is first energy equation, that is del U by del V T is equal to gamma del P by del T into V del T V minus P. du is equal to CVdT plus T del P by del TV minus P. These ones actually you have to remember a bit. Otherwise, yeah, I have to remember this ones. So fast energy equation. Now this next is your second energy equation. Del U by del P T is equal to minus del V by del T at P as P del V by del PT. Second energy equation. Or du is equal to CV dt minus T del V by del T. Okay. Yeah. Next, write down a real gas equation. Real gas equation. Real gas equation is P plus A by V square plus V sorry into V minus V is equal to RT. Okay. Van der Waals equation is called. This is for one mole only. Alright. So here critical volume. Just remember this. Critical volume is 3V. Critical pressure. How will you calculate it? You just take the differentiation. Okay. Critical pressure PC is A by 27 V square. You can take the differentiation and calculate this. No need like critical temperature. Just remember it. If it comes in option, you can directly take it. TC is 8A by 27B. Critical pressure is A by 27B square. Critical volume is 3B. Critical temperature is 8A by 27B. Okay. And there is another relation that is RTC divided by PCVC. R is a gas constant is 8 by 3 and is 2.667. This is same for all gases. Same for all gases. Okay. Now there is another formula boil temperature. Boil temperature TB is A by 2B. A by 2B. This is different for different gases. Okay. Next one is mean free path. Lambda is 1 by root 2 pi d square. So lambda you can see lambda actually is directly proportional to kt. Lambda formula also lambda is equal to kt by root 2 pi d square. So lambda like is directly proportional to t is inversely proportional to p. Lastly, some important relations. Important relations. Okay. ds is equal to cv dt by d plus del p by del t. V. It's okay if you don't remember it, but let me just write it. Cv minus cl is equal to del l dl by dt minus l by t. Cp minus cv you know is equal to r. Yeah. Cv is equal to del u by del t at v is equal to t del s by del t at v. Okay. Now Cp is del h by del p. Okay. At constant pressure is equal to T del S by del T at constant pressure. Yeah. Okay. Now TDS is equal to CPDT minus T del V by del T of P dP. Hmm. TDS is equal to CVDT plus T beta by K dV. Where what is a beta? Beta is called coefficient of volume expansion or volume expansivity. Volume expansivity, that is 1 by V. This is important. Del V by del T. Remember this. 1 by V del V by del T at constant pressure. Beta 1 by V del V by del T at constant pressure. Now K is isothermal compressibility. This is also important. Isothermal compressibility. Okay, that is 1 by V del V by del T. Minus 1 by V del V by del P at constant pressure. Okay, so these are some of the important formulas that you need to remember. Okay, so this is what we had from thermodynamics. Okay, we also statistical is also let, which we will do in like just let's take a 5 minute or 10 minute break. Then you can come back and have the statistical. We'll have the revision of statistical also. Okay, we'll complete it in only one video. Like no need to do two videos. Okay, let's have a bit of a break. All right, thank you. Come back after 5 minutes. So let's do statistical now, right? We have done the thermal physics, statistical mechanics revision. I hope you can understand the thermal part we did. Statistical. The ones we will only do the important ones that have the rank chance of coming exam. So, um, so volume in phase space, right? Volume in phase space. Volume in phase space is equal to d tau is equal to dx dy dz dpx dpy dpz. Okay. So d tau minimum is hq. Okay. Where h is a Planck's constant. Hmm. Okay. So density is what? Density rho is equal to ni by h is equal to ni by h. This is called number of phase point, and this is called volume of phase space. Volume of phase space. So number of phase cells, number of phase cells, number of states, number of states, that will be equal to V by HQ equal integration dpx, dpy and dpz. Okay. Now number of momentum states, number of momentum states range O to P, 0 to P, that is Gp is equal to 4 pi V by HQ PQ. Okay, 4 pi V by HQ into PQ. Alright. Now number of momentum states range P to P plus dP is GPdP is equal to 4 pi Vp square dP divided by HQ. Okay. This is a number of momentum states. Range P to P plus dPl is GPdP is equal to 4 pi Vp square dP by HQ. Number of energy states range 0 to E, GE is equal to V by HQ 4 pi 2 ME to the power 3 by 2. Okay? Very important. Now, number of energy states range E to E plus DE. That will be what? That will be GEDE. Whenever there is range D, the GD will be multiplied here, and that will be 2m to the power 3 by 2, 2 by V by HQ, e to the power half D. Yeah, alright. Yeah. Now, next is Maxwell-Boltzmann distribution function. Maxwell-Boltzmann distribution function. Maxwell-Boltzmann distribution function. Fe is equal to Ne by Ge, which equal to can be written as A e to the power minus beta. Okay, where Ne is your what? Number of particles of energy E, hmm, and Ge is your what? Number of states of energy E. Right? Number of states. G is a number of states. Ne is a number of particles. Okay. Next is atom. Uh, Molecular speed distribution is NVDV. NVDV is equal to 4 pi n m by 2 pi kt 3 by 2 v square e to the minus mv by 2 kt dv. The speed distribution function FVdv is equal to 4 pi n m by 2 pi kt 3 by 2 v square e to the power minus the square mv square divided by 2 kt dv. Right? Okay. Now, most probable speed. Probable speed. Most probable speed, and then here average speed, and here RMS speed. Yeah. Most probable speed, average speed, average speed. Most probable speed is dnv by dv is equal to 0. Average v average is 1 by n 0 to infinity v nv dv. RMS speed is v RMS is equal to root over of v square mean. Okay. Okay, wait. This is the main formula. Vmp is equal to root over of 2 kt by m. V average is root over of 8 kt by pi m. This one remember. Okay. Other ones you don't need to remember these days. This one remember. V most probably is root over 2 kt by m. V average is 8 root over 8 kt by pi. V RMS is root over of 3 kt by m. These ones you need to Remember. So from here we can see VRMS is greater than V average is greater than V most probable. Is that alright? Now quantum statistics, Bose-Einstein statistics. This was a Maxwell Boltzmann quantum statistics that Bose-Einstein statistics. Psi boson is equal to 1 by root 2 psi A1 psi B2 plus psi A2 psi B1. Yeah. Hmm. So if A is equal to B, then psi boson will not be 0. Okay, this is your called what? This is symmetric wave function, right? This is symmetric. Hmm. But what happens in Fermi-Dirac? Fermi-Dirac statistics. Fermi-Dirac statistics psi fermion is equal to 1 by root 2 psi A1 psi B2 minus psi A1 psi A2 psi B1. Okay, and if A is equal to B, then psi fermion will be what? 0. This is called anti-symmetric wave function. Okay, there is a minus sign in between. Okay, here spin is a 0 or integer, integral spin. Okay, but here spin is what? Here spin is what? Odd integer, half odd integer. Okay, okay. Next is thermodynamic probability. Thermodynamic probability P is equal to number of microstates corresponding to given macrostate divided by total number of macrostates. Microstates, sorry. Total number of microstates. So number of microstates corresponding to a given microstate divided by total number of microstates. So number of microstates is what? Omega is equal to n factorial by n1 factorial, n2 factorial, n3 factorial, but ni factorial. So microstates for different statistics. Microstates for Bose-Einstein will be ni plus gi minus 1 factorial divided by ni factorial gi minus 1 factorial. Whereas microstates for Fermi-Dirac will be gi factorial divided by ni factorial gi minus ni factorial. Okay. Gi is a what? Number of available states. Available states. Yeah. Is that all right? Next is a microcanonical ensemble. MC microcanonical ensemble here where NVE will be same. Okay. Canonical ensemble here TVN or NVT will be same. And the final one is grand canonical ensemble here TV mu is same. Okay. TV mu is same. NVE, NVT and TV mu. Right. So this is our NVE, NVE, NVE. These are same. Okay, and this one is rigid and insulating walls. Okay, rigid insulating walls. These ones you don't need to remember that much, right? Yeah. Next is partition function. Partition function. Okay, partition function is z is equal to summation I is equal to 1 to n gi e to the minus beta I. Alright. Hmm. This is for degenerate states. For continuous states, continuous means it will be integrated. Integration will have to do. This is for continuous states. It's continuous state. Okay. Now for distinguishable classical particles, for distinguishable classical particles, classical particles, Zn Tv is equal to Z Tv to the power n. Okay. For indistinguishable, we have to divide it. Indistinguishable classical particles. Okay, what we have to do? Zn Tv is Z Tv to the power n divided by factorial. Yeah. Now just this one's average energy is your minus del by del beta of ln Zn. Okay, that can be also written as kT square, kT square del by del T of ln Zn. Okay, average pressure kT low average del by del T del V of ln Zn TV. Yeah, mu will be minus kT del by del n of ln Zn TV. Okay, so just see through these things. I'm coming in 1 minute. Okay, so this is your average value of mu. Uh, then average like F is your minus kT ln Zn. Okay. Next item, partition function for an ideal gas. for ideal gas how much? Z is equal to 2 pi mkt by h square 3 by 2 v. Yeah. Now partition function for harmonic oscillator, this is important. Partition function for harmonic oscillator for harmonic oscillator is Z is equal to e to the power minus h squared omega by 2 kbt. Okay. 1 by 1 minus e to the power h squared omega by kbt, and this can be written as, this can also be written as 1 by 2 sine h squared omega by kbt. This is hyperbolic function, sine hyperbolic 2 sine hyperbolic h omega by kbt, or I can also write 2 sine hyperbolic h squared omega by kbt inverse, full inverse. This is it. For n particles, Z will be what? 2 sine hyperbolic h omega by kbt, to the power minus n. Is that alright? Yeah. So these are some of the concepts and formulas from statistical mechanics, right, and thermodynamics. So I hope you understood all these things. Alright, we have done numericals based on it, so you can check those out. And basically now try to revise concepts as much as you can. Okay, and numericals, whatever you have done, just see through them now, as like exam is on day after tomorrow. Okay, so yeah, thank you very much. Keep tuned to the channel where I'll be posting more one like this one shot revision videos in next 1 or 2 days for gate exam. Okay, thank you very much.